Figure P5-6. Looking at the other model and how it's constructed, not the exploded view, kind of see that there is an interference going on between these pegs. So if that was actually the situation, then we'd have to do something different. They didn't quite get a mate to there, so a lot of the in the process of our design review and going through these steps is that we're correcting errors along the way. We're looking for those interferences, checking for clearances, making sure that we're getting a desired result. And each level, as we go through the parts, is kind of the level one. You're doing a preliminary scan and view of is it going correctly. And then as it builds up from there, it gets in the assembly. That's another level of check. It goes over to the drawing. That gets checked as you do the exploded views, as you move and make the tolerancing and the dimensions and go through each of those processes. Then each one of those is a place that is a reality check, and is it going to be successful? We make the parts, we do whatever it is that can it be assembled? Is it going to go together with a minimal amount of effort? All right, so I'm going to bring in one of the C brackets first, change the configuration, hit the open, and since this is pretty much at the center, if I go ahead and hit OK, I finally have one that is coming in the orientation, so I can show you that if we turn on the origins, the origin of the part and the origin of the assembly actually joined up there, and I can leave them with the F. I don't have to do anything additional there. Alright, so if I wanted to check, there's the origin of the assembly. I expand out, I can see all of the features, the sketches, the mate reference. Haven't applied any materials yet. And then the origin of the part also in that same relative location. It may not I may have managed to move it a little bit, but because I just hit the checkbox, I'm pretty sure that it's origin to origin. Alright, so bringing this in, I'm going to bring the next one, and I'm going to stay with the face-to-face. I'm still not committed to the edge-to-edge. And then it's kind of falls into the category still of, if we do enough of these, everybody kind of adopts their favorite preferred methods, and it's really hard to break those habits. Alright, so we're going to bring in a plate, and I'll stay with the insert components. And we're going to bring in a spacer plate, and this is going to be a 2x3. And I'll open, and my mate references were on the bottom. And since I'm not bringing in the C bracket, well, I'm kind of getting what I get there. Alright, so I don't have too much to work with here. Let's go ahead and make that concentric. I wanted to kind of show some of the other possible patterns or things that we could utilize. And so in this case, rather than going parallel, and I would want to check the alignment and the interference since these are incoincident. And this would be a great place to pick up our stack up of tolerances and positional tolerances that as the pegs grow or shrink and as the holes grow or shrink and are able to align, and the tolerances on the widths, all of those stack up to positional tolerance, and when we're this tight, will these end up being a fit, or will they go into to bind and not be able to assemble? Alright, so I'm not going to get the pattern that I want, so I think I'm just going to go ahead and drag and drop. So rotate over a little bit, Control Select, drag to the position, one more Control Select, and these will go to those whole locations. Bring this one around, and we can go parallel to or coincident. And so it rotated in. I kind of expected it. Well, with coincident, it could only go parallel. Possibly could have brought it around the other way. So it is kind of interesting on some of the selections of what we can get. All right, so we need an L bracket, and we're really going to take advantage of these configurations now. If you built all these parts individually, then I should be getting kind of the sense that bringing in the items as separate components is a little more time consuming. Alright, so L bracket, go ahead and accept. I can bring that one around. I'll just go ahead and make that parallel. If it accepts it, and we'll see maybe a little bit of a hurry there. Stay with the parallels. Rotate over a little bit, Control Select. I'm not seeing my point. And not quite getting that one. That one's I was going to see if I could do another contortionist, but it's not cooperating. I'm not getting that that selection that I wanted, so I'll go back to the standby concentric. And coincident. And we'll rotate that around a little bit closer and make it parallel. Okay, so in the preview, kind of saw that the 2x3 was setting down. We can verify that and the gaps by going concentric. That wasn't quite what I wanted, so the quick way to reverse that would be to expand and then expand the mates. Go into the concentric and then flip the mate alignment. Alright, so when that rotates up and over, I can pick up another concentricity. Alright, so if this doesn't line up, then I know that there's a mismatch or change in dimension, and sometimes it only needs to be a couple tenths of a whole lot of nothing for it to not be able to solve. Alright, so creating that little bit of a gap, and then setting the coincidence, and that gives us our stack up. Alright, so we have another 30, a couple of 20s, and a couple of 20s, so we'll bring in the pegs. I'm going to go ahead and save this since I'm getting a little bit of a graphics drag or processor is working on this one, so save. Alright, so bringing in the pegs, just do an insert component, grab a peg. These are going to be the 10x20s first, and then I can hit tab, and that will work. Shifting over, Control Select, and a tab. And it doesn't necessarily have to be the first one. I think it's going to be able to select and tab. Alright, a lot of this is do not hesitate to zoom up to the part if you cannot make a selection or cannot see, and I let go too soon on that one. Either that or it's floating out in space somewhere. Alright, so Control 7 also has that ability to, if it did throw something out into space, it would be able to zoom out far enough to let me know that I lost it. Alright, so that one goes to a 10x30 and that one goes to a 10x30. And when we switch over into the drawing and look at some bill of material tables, then we should be seeing those show up as part of our mix. Okay, so in this process, there aren't too many things. It looks like everything would go into to bind and not be able to rotate around. That one gap on the base has a little bit of an issue. And this time I'm not going to go through the process of locking the rotation on the pegs. We're just going to leave it. I could gather up all of the brackets and all of the spacers and go through the process. The bill of materials really doesn't care. I don't have to. If I wanted the spacers, spacer plates listed first, I would need to drag those to the top because it is going to go in the order that it finds them. So as we do those tables, we would see the bracket, and it would count, whatever, 4 brackets, 5, 6 brackets, 4 C brackets, and the 2 L brackets, and then it would go to the spacer plate. So based on that, I would see the C brackets, the spacer plate, and then the 2 L brackets, and then all of the pegs. So if there's something in particular that you want it to, these are going to be the most, or that you want the bill of materials to kind of have an order, then we can start planning for that now and set the items in place. A lot of times that first item, that first component that comes in, that really is the base, or we want it to act as the foundation for the rest of the assembly. So it pretty much stays there. Okay, we got a couple more assemblies, and then we can get on to those exploded views and drawings.